Hi guys, today we'll see thread. What is a thread in Java? How we can create a single threaded or multi-threaded application through Java, and what is the life cycle, and how we can set priority for the threads, how we can uh, synchronize our threads, and how to create threads. So there are two ways, like there's a thread class and runnable interface. And what is the current thread? So there's a current thread method which help us to retrieve current thread. Let us have a closer look on this now. And so look at here. Thread is the sequential flow of control in a program. Is not a program on its own, but runs within a program. So if you write a program, inside that one thread is running here. Every program has at least one thread that is called the primary thread, and that you can retrieve through the current thread methods. So this method belong to your the thread class. So you can say thread dot current thread, and that will give you the current thread, and then you can do whatever you want. Like, I mean, you can start your threads, you can stop your threads later. So it's also referred as a lightweight process or execution context. So there's the two things we are having, say process and thread. So there's a difference between process and thread. While process is called heavyweight and thread is called lightweight or execution context. Let us say you are starting MS Word. Okay, so when you start MS Word, what happened? One application get started, means one process get started, right? Now in this process we are having multiple threads. Let us say you are doing some find and replace you are using. You are trying, say, spelling check, you are spelling check you are trying. You are doing some editing. So for all this we are having some threads, and that is happening. So all these threads share the process memory which has been occupied during a startup of the application. So that application can have multiple threads. Okay, if one application having one thread, we can say it is a single threaded. If it is having multiple threads, then we can say it is a multi-threaded applications, right? So we can create multiple threads in our program. Now look it. So in Windows platform, if we go to the task manager, in the task manager we find the list of the applications, right? So let us say this is my applications which are running in the Windows. Even in Linux also there is a process manager. So here we are having this much applications are running, right? For every application there is a one process. So look at here, if you go to this tab, you get a process list, and every process is having unique PID, that is the process ID. Okay, if you want to kill the process, you can just select the process and then say end process there, right? If you want to kill here, just select this and say end task, so it will kill the process. In Linux we are having kill command which will kill the process. Okay, so if you have started 200 application, okay, all this listed and all this running as a process in our system, and that process may have some uh, threads, and that threads are working and sharing the same memory which has been acquired by the process. Okay, so look at this process. We are having number of process running, like if we can say notepad.txt, beanbud.txt, all the exe file it is listed here, and all this exe file, I mean all this process is having some unique PID which is displaying here. And all this process, how much CPU utilization, how much memory utilization it is giving you, and who is the users for that application, right? Here you can see CPU usage and current memory usage and all. If you want to end the, close the notepad and all, so just select it and say end process. So it will end the process. If you're ending from here, you are not getting your data saved. If some data is unsaved, you will be losing from this place if it is not proper saved. So, okay. Single thread application, an application that is made up of only one thread is called a single threaded application, and that will perform one task at a time. So if you can see this image, what is happening here, thread is executing one by one, right, like this. Okay, so it is just moving one by one, only one thread, there's no other threads are running, and there's no interaction between that, right? Next is the multi-thread application having more than one thread. Okay, so multiple threads in an application run at the same time, perform different tasks and interact with each other. So let us say I have a multiple threads. So one thread is working other work, one thread is working different jobs. So could be the different threads and having different functionality. It could be the possibility that one thread is interacting with the other threads to get the updated one and perform something else on that data, right? Now, how we can create a thread? And before understanding that, you can look at here, two threads are running parallelly here, and they can interact each other here. Okay, thread can be created with any of the two ways. What is that? One is the making a subclass of thread, second is a implementing a runnable interface. So why it is two technique they have given? The class is okay. So what you do, let us say you're writing here a class. Just I will come to on this place and I'll tell you here. So let us say you are writing here a class X thread. Okay, XT is something I've written. Open and then close. So if you're writing here just extends thread, it is enough. Okay, this class will have the thread functionality. We can write here run method, so something we can do and it will function. But why then it is a runnable interface? Now there's a other thing is what, let us say you're having a class X and inside that you are saying extends by. So you are already extending one class in X and that is by, right? So can I write extend again? No, because multiple inheritance is not in Java, so we cannot write extend thread again. Or I cannot write extend by comma thread, right? So there is no option here. So there's a one options we are having what, implements runnable. If you are implementing this runnable interface, you have to override public void run method and you have to write some code here. This is, so I hope you understood. Now I give you another example in this scenario. Let us say you are having class X and this you want to make a applet, and applet should be extended from either JApplet class or applet. So that is a compulsory for making applet. You have to extend JApplet. And in that JApplet, or your applet, you want to do the functionality of thread. Can you do? No. So in that case, you require this guy, implements runnable. You can override this method and write the code and enjoy with thread, right? Okay. So I hope we understood the thread class and runnable interface. What is the use of this two guy? Okay, have a closer look on this. Is used to construct access individual threads in a multi-thread application. If you want to create a multiple threads, different types. Okay, go for extend thread. Okay, let us, I want to make a consumer thread, I want to make a producer thread. So what we'll do, we'll make a consumer class extend thread, we'll make a producer class extend thread, right? We'll do like that. If I want to make a customer thread, so I'll make a customer class and extend thread. You want to make a supplier thread, so I'll make a class supplier and extend thread. So it will be the different type of threads working individually. A separate thread can be created by extending the thread class. So this is the scenario for our code snippet given here, which help you to create a thread. Okay. Next, runnable interface is needed to create a thread whenever your class is already extending some other class. So if you're using already, like I have extend some other class, as I said, in the case of applet you have to extend applet, that is a compulsory. So you cannot work with the thread. So now we are having facility there also, that we can say implements runnable, and we can override the run method, and we can write the code here whatever the functionality we want from the thread. Okay, look at this life cycle of thread. If a thread is getting created, how long this will exist? So it is saying that if, let us say I just create one thread, so we can say it is a one stage, that is newly created thread, and we can say it is a born stage. Okay, so it is just born now. And if you're calling start method, I just write a small code here. Consider you are having a thread class, so you are just writing here thread t equal to new thread. So if you're writing this code, means one new thread is getting created, and that name is what? T. And then you can write what? T dot start. So once you say T dot start, the start method will call. Okay, what I mean, if you say here T dot start, so this will call the start method, and the start method will call run method. Okay, so this guy will call a what? A run method. Okay, I just write here again, T dot start will call a run method, that we are having public static void run, right? Now this run method, if executing, then we can say it is a runnable. My thread is runnable, it's running. Once we are saying thread dot sleep, so we are saying what? Thread dot sleep means say T dot sleep for 500 millisecond. It means it is a half second. Okay, so it will go for sleep. So sleep means it is not runnable. Not runnable means it is a block state. So it will go to the block state and keep waiting to get this time elapsed. Once the time is getting elapsed, it will automatically back up and come back to the here runnable state and start working. So that is what sleep. There's no backup method. I mean, if I'm sleeping for 1 second, automatically it will wake up after 1 second as the time getting elapsed. So Zavim will keep taking care here at this place. Okay. Now once you are saying T dot suspend, so again it will go for block state T dot suspend, but this will be keep suspended unless and until you are saying T dot resume. So once you have to call the resume method, and then that will get resume. But these two method has been deprecated now. So this has been deprecated, this has been deprecated. Now we are using bait and notify. So once you are saying t.bait, it will go for block state, and then if I say notify, it will again come back and start working. So that is what bait and notify. Both are used like together. So once if you're saying bait, you have to call notify, then only it will. Now consider you are writing one program and there it is asking for enter something. So your application is betting from user that to get something, right? So user is just taking time to enter something. In that case, what will happen? Your thread is not runnable. thread will go to the block state and keep waiting here. Once you are entering something and say enter, so one interrupt will happen and it will come back to the runnable state and start working, and then it will say enter age, enter name, something like that. Okay. Once you are saying t dot stop, then thread will get dead. If you are saying t equal to null, also it will become dead. So that is a normal death of the thread. Now what you are doing here, let us say you did thread t equal to new thread, and then you don't do t dot start, you write here t dot stop. You are calling a stop method. So it will become dead here, and this is called premature death of thread. This thread has not done anything, just started and become dead. So it is a premature death. So I hope you understood this whole life cycle of thread now, and let us understand the in details. New state, as I said, if you say new thread t equal to new thread. Runnable means it's ready to run state. A thread starts its life from runnable state. A thread first enters runnable state, after that invoking of a start method, but a thread can return to this state after either running, waiting, sleeping, or coming back from the block state also. On this state, a thread is waiting for turn on the processor, so it will be getting time of processor and start working. So that's the waiting area of getting processor time. Running a state, a thread is running a state, that means the thread is currently executing. So there are several ways to enter in a runnable state, but there is only one way to enter in the running state. The scheduler select a thread from the runnable pool. So if you are creating thread and you are saying t dot start, okay, it has come to the runnable state, right? Now from runnable to processor, who will do? Now your operating system will pull your thread from runnable to running a state. So operating system can only schedule your threads and then it will getting processed, because that is it is not in our hand, right? It's up to the scheduler. Job scheduler is there, so that depends on the some algorithm again. Dead state, as I said, a thread can be considered dead when its run method is complete, or if you're saying null, t equal to null, and if you're saying t dot stop, could be blocked. A thread can enter in this state because of waiting the resources that are held by another thread. Okay, as we have seen, different states that may be occur with the single thread. A running thread can enter to any non-runnable state depending on the circumstances. A thread cannot enter directly to the running state from non-runnable state. So first it will come to the runnable, and then scheduler will, once it will, then it will go for running. Okay.